Everyone got my email? Everyone got my email for what's covered on the test? For yes, it was before. It was before break. It was a long email. No, it's covering on this coming Wednesday's test. Yes, it's in there. Okay, guys, check out. Can you do me a favor? Can you go back in the back room there? And on the can you go back? Can you go back in the back room? There's the compressor. There's a big red dial. Turn it to off.
On what?
On the compressor in the back room. Just pull the door. There's two compressors. It's the compressor way in the back. It's that one. Should be a dial says red dials. Turn it to off. Okay.
Wait, this is for this test?
This coming test, yes. So the test is about graphing, velocity, acceleration, okay? It's dealing with all of the equations that we've used, up and including intersections, okay? Intersections or collisions, so to speak, right? Where two things collide, right? Correct? Everyone understand that? Where I'm either having to hit a specific point on the ground, or I have two vehicles coming towards each other at a different angle, and I need to be able to make sure that they collide correctly. Does that make sense? Yes? Okay. All right. So the big connector there, what's the connector between those two items? If I'm looking to have one thing collide to another thing, what's the big connector between? Time, right? The time has to be the same for everything, so that your time is what's going to determine whether you're colliding or not. You guys have to both be in the same position at the same time. If you're not, then you're going to miss each other. Does that make sense? And whether that is someone jumping off of a building to hit a target, horizontal with two directional motion, or if that's two vehicles sort of coming towards each other and hitting at a certain location, it's the same concept. Does that make sense? Yes? Okay. So let's do a practice problem. You guys ready? Okay. So let's say we've got some sort of object. Let's say we've got a cannon. All right. And let's say, I'm sorry? I am recording this, yes. Okay. So let's say that the cannon is going to launch off my cannonball in this direction with a specific velocity. Okay. And let's say I have some sort of target, some sort of cushy target, okay, some sort of mattress or something, right? And I want to get the cannonball into the mattress, okay? Let's say that our height is 89 meters above the top of the mattress, of the cushion. Okay, so we know that that's the height, okay? And let's assume that our initial velocity at, let's call it 30 degrees, our initial velocity of the cannonball is 100 meters per second. Yes?
Are we going to take into account how tall the cannon is or not?
No. Oh, yeah. Yeah, you're right. Let's do it this way. Thank you. Let's just go right up to here. Okay? So, yeah, don't get too crazy on that part. So we've got 100 meters a second at 30-degree angle. Okay? What I want you to tell me, two things. Okay? Actually, we'll do three things. What's the position that the mattress has to be in order for the ball to hit the center of the mattress? I'm measuring to the center of the mattress from the vertical part of the clip. I want you to tell me the delta time it's going to take to do that. So what's the distance for the mattress? What's the time it's going to take for it to hit the mattress? And then I would like you to tell me the maximum height. Max height. And actually, let's do this as well. This should hit a lot of different things. Let's do the velocity the velocity of the cannonball final. This is our initial, this is our final. So that velocity is a velocity vector, right? So it's not just the vertical component and the horizontal, it's the combination of the vertical and horizontal. Does everyone understand that? Everyone get that? Okay, go. Really fast. What are the things you got to do? You got to really let's focus on the process. What is it you have to do? What are our steps? Draw a picture first, right? That's good. We've got one now, but you should draw your own picture. Then, Netta, what else are you going to do? What's the next thing you're going to do? Lay out my facts, right? What's the first fact? What's the first fact you have to identify?
Whether it's velocity or acceleration.
Okay. What is the type of motion that you have? Do you have constant velocity and constant acceleration? And what's the modifier on this? Is what kind of motion do we have? We have both two-direction motion. We have vertical and horizontal, don't we? So you have to determine in the vertical direction what kind of motion you have, and the horizontal direction what kind of motion you have. Does that make sense? Everyone clear on that? Okay. When you do your work, when you show your work, you need to show me all of the variables. You need to show me what you're doing. You need to show me these steps. Show me that you've identified what motion you have in each direction. Show me that you've identified what variables that you have. Show me the equations that you have options for and which one you're going to use and kind of why, right? So go do that, and I'll walk around. Guys, this has a number of things in it, okay? So a number of things in it. But this is a basic problem you should be able to do, guys. Shh. Okay. So, like we talked about, what's the first thing we have to do? What's the first thing we have to do?
Break it down. Draw a picture.
We can draw a picture, okay? And then we gotta lay out our facts. Okay, what's the first fact we have to figure out? It's the first fact we have to declare. The first fact, most important fact. No. What? No. What's our most important fact about this problem?
Break it down.
Not even breaking it down. I know that I have what kind of motion?
Constant acceleration.
Okay, I have vertical and horizontal, and for the vertical motion, what do I have?
Constant acceleration.
It's constant acceleration. For vertical, right? Because what's acting on it? Gravity. For the horizontal, guys, what do I have? For horizontal, I have what? Constant velocity. Okay. Shh. Okay, right away, guys, when you know that, what do you know about the horizontal component of the velocity at the end? What do you know about the horizontal component?
It's the same as it is at the beginning.
It's the same as it is at the beginning. If it's constant, the horizontal component of the velocity, because it's a constant velocity, that means it doesn't change. So whatever the component is, the horizontal component at the beginning, that means the horizontal component at the end is what? The same. Right? Horizontally, the motion of the object never changes. David Dentino, does that make sense?
What?
Does that make sense?
That they're the same? Yes.
Yes. Okay, does everyone understand that? It's very key. Okay. All right. So what equations do I have for my constant acceleration? Give them to me. Give me that first one, basic. Acceleration equals what?
Delta V over delta T.
Delta V. I'm gonna do it this way, just so we're clear. It's V final minus V initial over delta T, right? Yes? Everyone see that? That helps me determine, because I'm going to be breaking down final initial velocities. What's another equation that I have? What's another equation that I have?
Delta V equals A times delta T.
That's the same thing as this one, isn't it?
Delta V equals 1/2 delta V.
Okay. My delta distance is equal to V initial times delta t plus 1/2 a delta t squared, right?
Yeah.
What's my third equation? My third equation I can use.
Velocity final squared equals velocity initial squared plus 2a times delta t.
Times delta d, right? Okay. What equation do I have for horizontal velocity? Or excuse me, for horizontal constant velocity? I've just got one, don't I?
V
What is that?
T over delta t.
Velocity equals delta distance over, or let's say our final distance, our distance final minus distance initial over delta t, correct? Okay. All right. So what are my facts? Let's follow Olivia's scenario here. Okay. I really like the way she set that up. It was very clean. Okay. Oops. Okay. What are the variables that I need, guys? What are the variables that I potentially have here? What are my vertical variables that I have? What are all the vertical variables? Listen. Okay. So it's my distance, which is my y initial, my y final. What else? Okay, my velocity y initial, my velocity y final. Do you guys see how I'm doing this? Breaking them all out like this. What else do I have? I got two more things. Acceleration in the y, and what's my last one? No, my delta time. Initial height is my y initial. But these right, you don't have them, but these are all the possible variables. List them all out. And then you can start to fill in the blanks of what you have and what you don't have. Does that make sense? Okay. So let's lay this out now. I've got my little grid. What is my initial height? My initial y position? 89 meters. What's my final position vertically? 0 meters, isn't it? What's my velocity initial in the y? How do I figure that out? Okay, so if I have my, I have my triangle where this is 100 meters per second. I have my Vx and Vy, correct? And so if this is 30 degrees, then Vx is equal to what? Come on, guys. What's Vx equal to? Give me the equation. Don't give me a number. Give me the equation. 100 meters per second times cosine 30 degrees. Does everyone see that? Yell at me if you don't understand how I got that. Okay. Vy is equal to what? 100 meters per second times what? Sine 30. So what's my Vy? Sine 30 is what? 1/2. So it's positive 50 meters per second. What's my final velocity vertically? Do I know it? Don't know it. No, we don't. The final velocity vertically?
Negative 65.15 meters.
But you have to calculate. We're initially laying out the facts. Okay, what's my acceleration in the y, guys? Okay, and what's my delta time? Not Sam Jeffries. We don't know yet. Okay, now let's do the same thing for my x position, for my horizontal motion. What are my variables? Line them up. X initial. X what? V what? Vx initial. Vx final. What's my acceleration? Okay, acceleration in the x, and then I have delta t. Right? Correct, guys? Now, what's the beautiful thing about this? What's the magic key thing you have to know? What about time? They're in both. In order for them, they're the same in both. If you want them to know where they are, this ball is always going to be in the same position. You know, it's always going to be When it's at the right vertical position, it's going to be at the right horizontal position at every point in time. It's not like the ball splits up, right? It's one object. It's always intersecting with itself. So you've got, the time is always going to be the same, okay? So my time is the connection between there. I don't know my time yet. What is my x initial position? 0 meters. What's my x final position? Don't know. What's my x initial, x velocity initial?
Oh, 86.6.
How much?
86.6
86.6 what?
meters per second.
Meters per second. What's my final velocity horizontally?
86.6.
86.6 meters per second, isn't it? Right? It's constant. What's my acceleration in the x?
0.
Why is it 0, guys?
Constant velocity.
Because it's a constant velocity and we have no change. And what's my time? We don't know. Okay. So at this point, I have this one equation, right? I've got velocity equals my final position minus my initial position over time. Do I have my final position? Do I have my final horizontal position? Everybody? No. Do I have my initial? Yes. Do I have my time? No. So I have one equation and two unknowns. So can I solve this yet? No. I need to figure out my time. Okay? So that means I got to put the horizontal on the back burner at the moment. Do you follow? Do you see the logic in how you're doing this? Right? So the vertical part, let's think about this. We're asking for a couple of different things. We want the change in distance horizontally. Well, I could get that if I knew what? I get the horizontal if I knew the time. Can I figure out the time from my vertical? How do you do that? How could you do that?
With the delta equals A.
Okay, so you can see
Or you have to find the final velocity. Yeah, you have to find the
there's a couple. Look, you've got a couple of options here, right? You've got two equations that involve time. What are my two equations that involve time for constant acceleration? Delta v over delta t, and my delta distance equals v initial times time plus 1/2 at squared, right? Which of these equations could I use? The delta distance equals v initial, right? I can't really use the first one because I don't know my final velocity yet, right? So finish this up for tonight, guys. Finish this up for tonight.